James' achievements on the web have exceeded our expectations, consisting of a 6.5-meter mirror, a sun shield the size of a tennis court, and a complex array of instruments cooled to temperatures near absolute zero. The telescope observes the sky in infrared radiation, revealing details of the universe just after its birth 13.8 billion years ago. It captures images of stars born in clouds of dust and collect faint light from the deepest of the universe, exploring its darkest corners. The infrared instruments of the space-time network are also useful for studying strange and bizarre worlds. In particular, James Webb has focused on Proxima B, capturing the sharpest image of our closest known neighboring exoplanet. What's fascinating is that what it has revealed goes beyond our expectations. In January 2024, we have reached a remarkable milestone in our understanding of the universe. For millennia, humans have observed the sky, wondering about points of light in apparent infinity. Just 3 decades ago, we began to discover planets orbiting other stars through a variety of methods. Now, 55 confirmed exoplanets and 10,000 additional candidates. We are in a new era of astronomy, exploring fascinating and diverse worlds beyond our own solar system. Planet formation exhibits remarkable diversity, determined by a number of factors including the chemical composition, geological activity, and atmospheres. When findings point to the presence of worlds with chemical elements even superficially related to life, the discoveries are significant, providing answers to some of our questions about the cosmos. However, deeper questions remain. In this context, the mission of the James Webb Space Telescope is focused on exploring the atmospheres of exoplanets for signs of life in other corners of the universe. Although James Webb is an infrared telescope, which raises the question of its suitability for studying exoplanets, it will use the transit method for this purpose. This method involves observing the light from a star as a transiting planet passes between the star and us. Collaboration with ground-based telescopes will complement this research by allowing measurements of the mass of planets using the radio velocity technique, which detects the slight wobble induced by a planet's gravitational tug. In addition, James Webb will perform spectroscopy of planetary atmospheres and carry coronagraphs to obtain direct images of nearby exoplanets. Although these images may appear to be simple points of light, their detailed analysis will reveal valuable information, such as color variations that may indicate seasonal or rotational differences in vegetation. Spectroscopy, which involves measuring the intensity of light at different wavelengths, is fundamental to unraveling the atmospheric compositions of exoplanets. When a planet transits in front of a star, starlight passes through its atmosphere, and the elements and compounds present in the atmosphere absorb light at characteristic wavelengths. This absorption is reflected in the observed spectrum, making it possible to identify the presence of elements such as sodium, methane, or water. An infrared telescope is essential for characterizing the atmospheres of these exoplanets because many of the gases relevant to the search for life, such as water and carbon dioxide, emit and absorb light in the infrared range. In addition, this wavelength provides valuable information about the temperature and chemical composition of the atmospheres, which contributes significantly to our understanding of the habitability of these distant worlds. Observation in the infrared spectrum offers the advantage that the molecules present in the atmospheres of exoplanets exhibit a wide range of spectral characteristics. The ultimate goal is to discover a planet with an Earth-like atmosphere, and in this effort, to find an Earth 2.0, the James Webb Telescope has turned its attention to Proxima B. This enigmatic exoplanet, located light years away, is the closest known neighbor. Proxima Centauri b is a super-Earth orbiting an M-type star with a mass approximately 1.27 times that of Earth and an orbital period of 11.2 days. This planet lies at a distance of about 0.085 astronomical units from its star within the habitable zone. However, the extreme intense ultraviolet radiation it received from its star poses challenges to habitability, as this radiation can erode the atmosphere and compromise the presence of elements essential for life, such as oxygen and nitrogen. The habitability of a planet depends not only on its location in the habitable zone, but also on the ability of its atmosphere to maintain conditions suitable for life, such as climate regulation, radiation protection, and preservation of necessary chemical components. In addition to Proxima B, James Webb is also interested in other exoplanets, such as WASP 107b and the wandering worlds of the Orion Nebula, which challenge our conventional conceptions of planetary formation. These recent discoveries have opened up new questions about the formation and diversity of objects in the universe, challenging our existing theories and stimulating continued explorations of the cosmos. We were on the lookout for astronomical tiny objects, and we have found them, even as small as half of mass of Jupiter, floating freely in space, unbound to any star. Physics tells us that objects of such a small scale should not exist, but we seem to have defied those laws. These bodies, which are technically not planets, have been dubbed Jupiter mass binary objects because several of those identified come in pairs. Although these two jumbos are 2 of 1 million years old, which is very young in astronomical terms, their first surface temperatures reaching a scorching 1,000 degrees Celsius, although they will eventually cool. Although these objects may exhibit interesting atmospheric features, such as the presence of steam and methane, they are not considered capable of harboring extraterrestrial life, as their surfaces could not sustain liquid water, even during their brief period of moderate temperature. These observations have focused on the Orion Nebula, a region of massive star formation located 1,344 light-years away from Earth. This nebula, visible to the naked eye as a fuzzy star in the sword of the constellation Orion, is a celestial spectacle filled with clouds of dust and gas, where explosions and gravitational collapses occurred and give rise to formation of stars and other celestial objects. The most recent findings have puzzled astronomers, especially the presence of numerous pairs of Jupiter-sized objects. The question of how these objects can be flown out of a star to orbit in chaotic interactions and then rejoined remains an enigma. Even experts like Professor Matthew Bates, head of astrophysics at the University of Exeter, acknowledged that they have no definitive answer to this anomaly. It seems that our current theories are not sufficient to fully explain these new findings. There is an unknown mechanism that is shaping these objects, something we have not yet considered. This type of discovery is quite unusual and challenges us in our understanding of star formation, an area we thought we understood quite well. It is a surprising result from which we can learn more about. Proxima B is an Earth-like planet orbiting the closest star to our solar system. What a coincidence! Although conditions on Earth are quite suitable for life, why settle for that when there are other planets that offer better characteristics such as balanced temperatures, fewer deserts, and a greater abundance of water? We're talking about the future of humanity, and scientists have identified some planets as prime candidates for possible colonization. These super-habitable planets, as Michio Kaku calls them, are fascinating and pose exciting possibilities for our future. Michio Kaku, the renowned physicist and co-founder of string theory, is optimistic about the future of humanity and the possibilities and opportunities that these super-habitable planets may offer. He firmly believes in the possibility of achieving immortality and, furthermore, aspires that in the future we will be able to colonize other planets and even entire universes. This idea arises due to the need to have settlements in places in case of something catastrophic happens on Earth, such as meteorite impact, supervolcanoes, or ice ages. In about 5 billion years, it is even predicted that the Sun will expand and consume Earth. The first steps to ensure our survival is to leave Earth and start colonizing other planets in our galaxy. The goal is to find Earth-like planets, or even better planets called superhabitable planets, that have even greater potential to harbor life than our own home. The term superhabitable planet was proposed in 2014 by Reid Herald and John Armstrong. According to them, the mere location of a planet within the habitable zone of its star is not enough to determine its actual habitability. Superhabitable planets are specific celestial bodies that offer a higher potential for harboring life compared to Earth. The common belief is that the Earth, as the only known planet with life, meets the psychochemical parameters necessary for the development of life. These parameters are key to life as we know it, and one of the essential elements is the presence of liquid water. It is for this reason that we search for exoplanets similar to Earth, in the hope of finding places where life can also exist. However, it is important to recognize that other types of planets may offer conditions equal or even more conducive to life compared to Earth. Contrary to the notion that Earth represents the pinnacle of planetary habitability, a superhabitable world could also be a mood with a richer range of flora or fauna compared to our own planet. Such a world would be shown as a higher degree of environment conducive to life. It is also important to note that not all rocky planets located in the habitable zone of a star are automatically habitable. Habitability depends on a variety of factors and is not limited solely to similarities with Earth. The concept of superhabitable planets can be complicated to convey as it challenges the assumption that Earth represents the pinnacle of planetary habitability. However, it is important to consider that our planet harbors an impressive array of complex and diverse life forms, suggesting that life can thrive in conditions very different from those on Earth. In the search for exoplanets, research needs to explore indicators that may reveal the existence of superhabitable worlds. Among the promising targets, Alpha Centauri b has emerged. Alpha Centauri b is part of the closest star system to our planet, which makes its potential exciting. However, so far, no planets have been confirmed to be present in this system, much less superhabitable planets. While there was a possible detection in 2012, it was refuted in 2015. Therefore, we do not yet know of any worlds in Alpha Centauri b. However, its neighbors, such as Proxima Centauri, are of special interest. Proxima Centauri is a red dwarf located only 4.2 light-years from Earth, making it an intriguing candidate to host not only habitable planets, but also possible superhabitable planets. Within the Proxima Centauri system, an exoplanet called Proxima Centauri b has been identified as residing in the red dwarf's habitable zone, along with other contending candidates such as Proxima c and Proxima d. Proxima Centauri b is one of the closest known exoplanets to our solar system, which has led to the question of whether this planet could be habitable. However, there are significant obstacles to life thriving here. Several variables complicate the habitability of Proxima Centauri b, such as the activity of the host star and tidal locking phenomena. The light emitted by Proxima Centauri is comparatively redder, which could reduce the interactions with certain organic compounds and decrease ozone production in the planet's atmosphere. This in turn could generate elevated levels of UV radiation harmful to life. In addition, Proxima Centauri b's orbit may be eccentric, which means that in certain parts of its journey, the planet could temporarily fall outside the habitable zone. These fluctuations could negatively affect its habitability potential. Another factor to consider is the presence of carbon monoxide in the planet's atmosphere. If these gases accumulate in excessive amounts, they could become toxic to living organisms. On the other hand, if Proxima Centauri b were to host oceans, higher oxygen concentrations could have a positive effect on the evolution of complex organisms. Tidal forces, due to tidal locking on this planet, would generate periodic cycles of flooding and drying in coastal landscapes. These cycles could trigger chemical reactions conducive to the development of life and promote the emergence of biological rhythms similar to the natural cycles we observe on Earth. In addition, similar cycles of flooding and drying would facilitate the mixing and distribution of nutrients in the oceans, stimulating periodic expansions of marine organisms, akin to what we know as red tides on our planet. It is important to mention that although red dwarfs, such as Proxima Centauri, are exceptionally long-lived compared to our Sun, their radiation is not conductive to photosynthesis as we know it. However, Proxima Centauri B might be able to support a different type of photosynthesis called anoxygenic, although its possibility is not yet fully confirmed. A 2017 study suggested that photosynthesis-based ecosystem on this planet could be about 20 times more productive than the one we find on Earth. The stability of the planet's atmosphere is a major challenge to its habitability. Even before Proxima B was discovered, researchers had been actively searching for exoplanets in the vicinity of Proxima Centauri. In the research conducted in 2008 and 2009, the lack of larger-than-Earth exoplanets in the habitable zone around dwarf stars, which include Proxima Centauri, was noted. Although these stars have on average 1 or 2 planets, only 20% to 40% of red dwarfs harbor planets in their habitable zones. Therefore, our search for a habitable planet in the Alpha Centauri system has not yielded many results so far. While it makes sense to search for exoplanets in the Alpha Centauri system, since it is the closest star system to our home, there are many other options in the vast expanse of our galaxy. So far, more than 5,000 exoplanets have been confirmed, and there are countless candidates awaiting new observations for verification. Work has been going on for several years to develop technologies for space observation, and today amazing machines such as the James Webb Telescope have been built. This telescope has left the whole world in awe with its new images of deep space and its amazing discoveries. The telescope uses very powerful space lenses that make it possible to see the first galaxies and stars that formed billions of years ago. After a long period of design and construction, and after several setbacks, the James Webb Telescope is finally producing its first result, representing the impressive result of an investment of about $10 billion. We invite you to join us to explore how this telescope has achieved the clearest image of Proxima B. And if you are interested in keeping up to date with news about the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Thanks to the James Webb Telescope, NASA and its international partners have been able to prove that many of the theories that were handled are true. This telescope will make it possible to observe phenomena in stars that, until now, were totally unknown to space science. The largest telescope ever built was launched into space on December 25, 2021. It is currently located at the L2 Lagrange point, 1 million kilometers away in the Sun-Earth halo orbit. Thanks to a 6.5-meter wide-range primary mirror and ultra-sensitive infrared instruments, the telescope has been able to detect the distorted shape of the red arcs of the galaxies that existed 600 million years after the Big Bang. The universe is approximately 13 billion years old, and the news are better. Scientists can interpret from the quality of the information being produced by the James Webb that the telescope is receiving information about the universe far beyond what has been expected so far. This may be the deepest visual range of the universe we have ever obtained. The James Webb Telescope has achieved a feat never before seen in human history by capturing images of the cosmos that surpass any previous expectation. The first images released by NASA are a complete new vision of the universe, which surprised even the experts. The goal of this mission is to solve the mysteries of the solar system, discover new worlds, and explore the origins and structures of the universe. NASA has worked in collaboration with the European Space Agency, the Canadian Space Agency, and other international agencies to make this project possible. The telescope has captured the hidden history of the universe through every stage of its evolution. which allowed scientists to better understand our place in the universe. In the image captured by the James Webb, exoplanets and distant galaxies can be seen in the deep universe, making it the clearest and most detailed infrared image of the distant universe to date. The first color photograph taken by the telescope was released on July 12, 2022, and did not disappoint expectations. The image unveiled by President Joe Biden shows the telescope's ability to fulfill one of its goals, which is to observe distant galaxies. The image shows a cluster of galaxies in the Bulan constellation known as MAX 0723, which lies at a distance of more than 4.5 billion light-years. The light reaching us from this galaxy was generated when the solar system was forming, and it has traveled across the universe until it reaches our eyes today. What is an exoplanet? Well, an exoplanet is a planet that orbits a star other than the Sun and therefore does not belong to the solar system. Of all the exoplanets known so far, none arouses as much interest as Proxima B. As mentioned before, the star orbiting this exoplanet is Proxima Centauri, a very cold red dwarf with a surface temperature of 2,872 degrees Celsius, 8 times less massive than the Sun and 500 times less bright. About 7 million kilometers from its star is Proxima B, which has characteristics very similar to those of the Earth, with continents, oceans, and probably life, with huge auras giving the planet a greenish color in both atmospheres. As a result of the intense flares expelled by its star, forcing the magnetic field to generate these huge auras. What you see on the screen is the most detailed image that the James Webb Telescope has ever taken of Proxima B. This planet is tidally locked. That is, the same face of the planet always points to its star. This means that the best area for life is the twilight zone. The surface temperature could be between minus 90 degrees and 30 degrees Celsius, and it takes about 11 Earth days to complete a full orbit to its star. And it has a gravity of about 1.23 times that of the Earth. Scientists are not yet clear whether Proxima B has an atmosphere, but if it does, the ingredients such as carbon dioxide, rocks, and water necessary for the formation of the biochemical cycles we call life would be present on its surface. The James Webb Telescope has succeeded in finding signs of water on an exoplanet called WASP-96b. The spectrum of this exoplanet's atmospheres has been analyzed in detail by the telescope, revealing the presence of water, haze, and clouds that had not been detected before. Although WASP-96b orbits too close to a star to have life, scientists hope that Webb will be able to study planets with Earth-like atmospheres in the future, looking for signs of life. NASA experts are very confident that Webb will meet its goal. The first list of images released by the telescope are spectacular and have been captured in infrared, including photos of the Saturn Ring planetary nebula and a star covered in dust and light. The scientist in charge of the project, Dr. Amber Straw, is excited about what they will be able to do with these images in the future. The James Webb Telescope gives us a stunning view of the Stephan's Quintet, a group of galaxies in the constellation of Pegasus, with clouds of dust surrounding its center. Stephan's Quintet is composed of 5 main galaxies: NGC 7317, NGC 7318A, NGC 7318b, NGC 7319, and NGC 7320. These galaxies are gravitationally interacting with each other, which has resulted in an interesting and peculiar features in their structure. NGC 7317 is an elliptical galaxy that appears to be relatively isolated for the rest of the group. NGC 7318A and NGC 7318b are 2 merging galaxies, which have generated intense star formation activity. NGC 7319 is a bar spiral galaxy with a deformed spiral arm due to interactions with the other galaxies in the group. Finally, NGC 7320 is a smaller spiral galaxy that appears to be farther away from the group and not interacting as directly with the other galaxies. Stephan Quintet is an interesting object of study for astronomers, as it offers an opportunity to better understand how gravitational interactions can influence the evolution of galaxies. These interactions can trigger star formation, deform galactic structure, and eventually lead to mergers between galaxies. The studies of compact groups of galaxies such as Stephan Quintet helps us expand our knowledge of galaxy formation and evolution in the universe. In addition, through his view of the Carina Nebula, Webb gives us a rare view of stars in the early stage of formation, studying the gas and dust that created them. Webb's ability to detect essential molecules will be vital for searching for organic traces on exoplanets. The telescope will continue to orbit and provide images and data of the universe, and it is hoped that in the future it will be able to study a planet with an Earth-like atmosphere in search for life. Although we cannot predict exactly what Webb will show us in the near term, it's fulfilling its noble task of helping us learn more about our vast universe. We cannot say for sure whether the James Webb Space Observatory will provide us with information about the existence of extraterrestrial life beyond our solar system in the future. However, the telescope will continue to provide new data and discoveries about the universe, and it's exciting to think of the possibility that this may present. If you like this video, we appreciate your support by liking, sharing, subscribing, and turning on the notification to stay up to date with our new content. See you soon.